Good day, I'm Arvin Enriquez, your subject teacher in General Mathematics. With this video lesson, we're going to discuss the topic Simple and General Annuities under your General Mathematics from Quarter 2, Module 4. Our lesson objectives. At the end of this video lesson, you are expected to define terms that are related to simple and general annuities. Second, illustrates and distinguishes simple and general annuities, and represent annuities to real-life situations. Now, let's discuss your simple and general annuities. So this lesson will tackle first the definition and types of annuities, and the difference between your simple and your compound annuities. There are types of annuity according to correspondence of payment intervals with interest period. First, your simple annuity. The payment interval is also the same as the interest period. Now, the question is that what is your payment interval? So this payment interval is the time between the successive payments dates of an annuity. So mean say that uh, time between the successive payments of that annuity is the same with the interest period. When that's happened, no, that is a simple annuity. Now, with your general annuity, it refers to an annuity where the length of payment interval is not the same as the length of the interest compounding period. So when the payment interval is not the same as the length of the interest compounding period, that annuity represents a general annuity. So what is the difference between your simple and your general annuity is that when you're dealing with your simple annuity, your payment interval is the same as your interest period. While in your general annuity, no, it is an annuity, no, wherein your payment interval or the length of the payment interval is not the same, no, as the length of the interest compounding period. So these two types of annuity or annuities is under your annuity certain. So, I mean, there are two types of annuity, your annuity certain and your annuity uncertain. So these two kinds of annuity certain, which is your simple annuity and your general annuity, so these are kinds of annuity certain. So for the classification of your simple annuity, no, it can be your ordinary annuity, your annuity due, your deferred annuity, while in your general annuity, so there are three classifications of this general annuity. So that will be your general ordinary annuity, your general annuity due, and perpetuities. No, as we can give no an example of these annuities, so it can be, for example, rent payment, your pension, your monthly payment of a car loan or mortgage, and many more. So if the payment for each period is fixed and the compound interest rate is fixed over a specified time, the payment is called an annuity payment. With this annuity payment, what are the things that we need to take note? before we consider that your payment is an annuity payment. So in your annuity payment, there is a fixed period and a fixed compound interest rate over a specified time. Now, with the accounts associated with the streams of annuity, payments are called annuities. Now, let's define what is your annuity. Your annuity now is a sequence of payments made at equal. So there is an equal or fixed intervals or period of time. So if there is a fixed intervals or periods of time, no, in your payments, this sequence of payments are called annuity. So these are the good examples of an annuities. No? First is your rental payment, your monthly pensions, monthly payment for car loan, and educational plan, and many more. So there is a lot of applications wherein we can see the concept of your annuity. Now let's talk about the annuities may be classified in different ways as follows. First is according to payment interval and interest period. So under this one is your simple annuity and your general annuity. So when we say simple annuity, it is an annuity where the payment intervals is the same as the interest period. When that's happened, when your payment interval is the same as the interest period, that annuity represent a simple annuity. While in your general annuity, it is an annuity where the payment intervals is not the same as the interest period. When that's happened, no, when your payment intervals is not equal or is not the same as the interest period, that annuity represent a general annuity. So those are the things that we need to consider or take note in defining your simple and your general annuity. Now, let's classify an annuity according to time of payment. Under this one is your ordinary annuity or annuity immediate and contingent annuity. So first, your ordinary annuity or annuity immediate, a type of annuity in which the payments are made at the end of each payment interval. So the things that we need to consider for this type of annuity is that the payments are made at the end of each payment interval. So if there is an agreement between the lender and the borrower that the payment interval is, for example, 3 months, then at the end of each 3 months, there should be a payment. That is a good example of an ordinary annuity, that the payments are made at the end of each payment interval. Now, in your contingent annuity, an annuity in which the payments extend over an indefinite or indeterminate length of time. Even there is a payment interval, the payment can be done, no, after the payment interval. Meaning to say that the payment interval can be extended or the payment can be done or payment can be made after that set payment interval. So there is an extension over an indefinite or indeterminate length of time. So that is a contingent annuity. Now, let's classify an annuity according to duration. So under this one is your annuity certain and contingent annuity also. Your annuity certain an annuity in which payments begin and end at definite times. So meaning to say there is a specific or fixed, or the payment interval is defined. No? We say, for example, if the borrower and the lender has an agreement that the payment interval between the first term up to the last term is only 1 year. So within that 1 year, the payments will happen. So it is an annuity in which payments begin and end at definite times. So meaning to say that the starting point and the end point are always defined with this type of annuity. Next is your contingent annuity. An annuity in which the payments extend over an indefinite or indeterminate length of time. So it can be extend over an indefinite or indeterminate length of time. So if, for example, again, if there's a set payment interval for 6 months, and with this concept of contingent annuity, it can be extend over that indefinite. Meaning to say, it can be there is an extension. No? It depends on how this setup will go through. So the payment is made at the end of each period. Such annuity is called an ordinary annuity. So it's an ordinary annuity based on the table that I presented a while ago from our previous slide. So if the payment is made at the end of each period, that annuity represents an ordinary annuity. Each payment in an annuity is called the periodic payment, or it can be represented by using your uh, big letter R. No? If you're asked to represent periodic payment, we can use your big letter R to represent this one. So each payment in an annuity is called a periodic payment. So the time between the successive payments dates an annuity is called the payment interval. So whatever the time between the successive payments or terms, that will be your payment interval. So the time between the first payment interval and the last payment interval is called the term of the annuity. So for example, there are 8 terms, or your payment is being cut for 8 months. For example, from the first day of this, from the first payment interval up to the last payment interval, the time duration or the time frame between those payment intervals is the term of annuity, which can be represented using your small letter t here. Next is the sum of the future values of all payments to be made during the entire term of the annuity is the future value or the amount of an annuity. We can use your big letter F to represent this future value or the amount of an annuity. So meaning to say, here in your future or the amount of an annuity, the interest was being applied to the principal. So this future value can be computed at the end, of the term of the annuity. Next, the sum of the present values of all payments to be made during the entire term of the annuity is called the present value of an annuity, which we can use your big letter P to represent this present value when we say present value, these are the sum of the present values, no, of all payments. Meaning say that there is no interest being applied on this one. So whatever the principal that this borrower needs to pay for the lender, no. So whatever the principal without the apply interest on it, and that is a present value of an annuity. So when we say present value of an annuity, that is the sum of the present values. And when you're dealing with the present values, meaning to say that this is a principal wherein there is no uh, interest being applied on it. So whatever this borrower needs to pay for each of the payment, periodic payment, no, that can be done on this annuity without an interest, that is a present value. So once we sum up these present values of all the payments that we need to or it can to be made, I mean, no, that is the present value of an annuity. So annuities may be illustrated using the time diagram. So the time diagram for an ordinary annuity is given below. So your time diagram for an end payment ordinary annuity is that for your zero uh, at the beginning, right after, for example, 1 month here, from zero to the first term of payment, no, of your annuity. So here there is a periodic payment R here, which you can see that we can map on the first term of payment. So as you can observe, the payment interval between the successive or the sequence of successive payments here are equal up to the last term of this annuity, no? Wherein in each of the term here, there is a periodic payment, which is your R. So this periodic payment up to the last term of this annuity are equal. There should be an equal time interval between your term, and there is a periodic payment in each term. So up to the last payment and up to the last term. So that's how we use time diagram for an end payment of an ordinary annuity. Now again for an example of a simple annuity on how we apply your simple annuity in solving a particular problem, no, for this one. So again, when we define your simple annuity, the payment interval is also the same as the interest period. So these are the things that we need to consider, no, on how we apply your simple annuity, wherein your payment interval is the same as the interest period. So for example, number one, under your simple annuity, so 50,000 pesos deposited every year for 5 years. So there is a 50,000 pesos deposited, no, every year for 5 years. Meaning to say after 5 years, there is 250,000 pesos being deposited, wherein we can apply your interest rate, which is 8% per year, or it can be per annum, no, compounded annually. So the solution here, notice that 50,000 was deposited every year, and it is compounded annually. Meaning say the first 50,000 will earn an interest after a year. So after a year, there is another 50,000, meaning to say that this first 50,000 will earn, no, first an interest with an 8% interest rate, no, compounded annually. Since the compounding period is similar to the payment interval, no, your compounding period here is per year, and the payment interval is every year. Meaning to say, after a year, there is another 50,000 pesos. And the compounding period is also per year or compounded annually. Then this is a type of simple annuity. So as you can see, no, when we define your simple annuity, the payment interval is also the same as the interest period. So with this example, the payment can be done every year. No, once we apply your interest rate, the interest rate will be applied, no, per year, compounded annually. So mean to say, it can be applied every year, no. So the cash flow of the given situation can be illustrated in the time diagram below. So your periodic payment here, no, for the first year, we can map your 50,000. So after 1 year, there's another 50,000 pesos to be deposited, no? And after 1 year, for the third year of payment, there's another 50,000 pesos. Same thing from third year to the fourth year. After 1 year, there is another 50,000 pesos. And up to the last payment, which is your fifth year. And there's another 50,000 pesos here. So that's how we illustrate simple annuity. There is a The payment interval are the same with the interest period. In each of the payment interval between your first year and second year of payment is the same rate of interest, no, that we can apply from your second year to third year to fourth year, and fourth year to fifth year. So that's how we apply your simple annuity with this uh, example problem, no, under this one. Now, after we view, no, the concept of your simple annuity in a time diagram, no, let's now compute, no, the future value of all the payments at the end of term, which is your t, which is equal to 5. So t, it represents your time or term, since it can be done in 5 years. So your t now is equal to 5. As you can see here, this will be your time diagram from first year of payment up to the last year of payment, which is your fifth year. Now, on how we compute, we are going to apply on how we compute your compound interest, no, here. So there is a 1 year. Uh, Once we apply, we start from fifth year, which is 50,000, no? And second will be apply on this one, and fourth up to the first year of payment, then 3 to the second year of payment. So we're going to apply your compound interest formula on this one, wherein we can apply your compound interest to the principal that is being deposited every year for the first year of payment, second year of payment, third year of payment, fourth year of payment, and up to the last year of payment, which is your fifth year. Now, in this case, no, and how we solve for the future value after, no, 1 year. So your 50,000 now will be multiplied to 1.08, because it can be 1 plus what? It can be 1 plus 0.08, so that will be equal to 1.08, because we can now apply, you know, the interest rate, which is 8% compounded annually. That's why it's 1.08 raised to 4, so that will be your time or term, because after 1 year we're going to subtract now your time or term here. So in this case, no, so that's why it is 4, no. That is, we subtract 1 to 5 to make it 4. Because after 1 year, we're going to compute future value, meaning to say that your time or term will be less by 1 year. No, can be less by 1 year. Now, for the second year of payment, so it's the same interest rate, it's the same principal. Now we're going to apply now here, no? We're going to apply now your 3. Why is that it is 3? Your exponent here is 3 because we subtract 2 to 5. In this case, that's why it's 3 because we are now after your second year of payment. And for the third year of payment, so after 3 years, no, it can be 50,000 multiply 1.08. Why is that? It is 2 because 5 minus 3 now, it's 2. Now, for the fourth year of payment, that is 50,000 multiplied by 1.08 raised to 1. Why is that? It is 1 because 5 minus 4, it's 1. Now, for the fifth year of payment here, since 50,000 here, why is that? It is 50,000. There is no 1.08 being multiplied to 50,000 during your fifth year of payment because 1.08 raised to 5 minus 5 can be equal to 1.08 raised to 0 when a number raised to 0 and greater than to it is a rational number. I mean it's a real number wherein greater than 0, so that is equal to 1, wherein 1.08 raised to 5 minus 5 is equal now to 1.08 raised to 0, and that 1.08 raised to 0 is now equal to 1. That's why it is only 50,000 here in your fifth year of uh, payment. So that's how we compute your future value of all the payments at the end of the term within that 5 years of uh, interval period. No. So add all the future values obtained from the previous step. So for your 50,000, so that will be equal to 50,000 also. So how we compute for the the future value at the end of this fourth year payment, that is 50,000 multiply 1.08 raised to 1, so that will be equal to 54,000, meaning to say that your future value at the end of your fourth year of payment is 54,000 pesos. No, now with your 50,000 multiplied by 1.08, that is 58,320, no, in this case, and 50,000 multiplied by 1.08 raised to 3, so that will be 62,985.60 pesos. So for 50,000, 1.08 raised to 4, so that will be 68,024.45 pesos. So once we total this one, so the total is 293,329.45 pesos. So that's how we compute, no, the future values in each term of payment in dealing with your simple annuity. But in this case, no, on how we total or add all the future values obtained from the previous step, and that this will be your 293,000 pesos, 329.45 pesos. So let's deal now with your general annuity. So it refers to an annuity where the length of the payment interval is not the same as the length of the interest compounding period. So what are the things that we need to consider in your general annuity? Please do take note that the payment interval is not the same as the length of the interest compounding period, and that annuity represents a general annuity. So a good examples of these general annuities is that first, the monthly installment of a car, lot, or house with an interest rate that is compounded annually. So the payment interval is every month. So for example, your payment interval here is 1 month. But again, the length of the interest compounding period is 1 year. because the interest rate is compounded annually or per annum or per year. So meaning to say that the payment interval is not equal to the length of the interest compounding period because the length of the payment interval is 1 month and the length of the interest compounding period is 1 year. So number one is a good example of general annuity. For number two, paying a debt semi-annually when the interest is compounded monthly. So this semi-annually represent 6 months, meaning to say that a debt or paying a debt semi-annually can be done every 6 months, while the interest is compounded monthly, meaning to say that the length of the payment interval is 6 months and the length of the interest period, no, compounding period with this one is every monthly. I mean every month, no, because the interest is compounded monthly. So the length of the interest compounding period is equal to 1 month. Now, in this example, the length of the payment interval is not also equal to the length of the interest compounding period. Therefore, this example is a good example of your general annuity. So for example number 2, for the general annuity, so find the amount of annuity of 700 pesos every 6 months, or it can be 1/2 year or semi-annually for 12 years of if interest is 6% compounded monthly. So the interest will be computed monthly, no? So solution. Here, the payment interval is 1/2 year or semi-annually is different than the interest period, so it's not annually, no? It is monthly. So based on the given problem, it is monthly. So this is a general annuity because your payment interval is 6 months and the interest period is monthly. Now, we must watch the interest period to the payment interval. If the payment interval is not the same with the interest period, then the example is a good example of a general annuity. So we must find the semi-annual rate that is equivalent to 6% compounded monthly. So for step number 1 here, using the formula A is equal to P multiplied by 1 plus I raised to N. So here it's the same concept on how we compute for the compound interest, no? So find the value of 1 peso invested at 6%, compounded monthly after 1 year. So your future value here, or the compound interest here is 1 multiplied by 1 plus 0.005. We convert this 5%. So it's not 5%. So please do take note of this. No, it is 0.005 because we divide your 0.006 by 12 because it is compounded monthly. So we need to divide your I or the interest rate by 12 because it is compounded monthly. So we need to cut this 0.006% by 12 for us so we can see what amount of this interest can be applied every month. So your N is 12. So if we apply or we substitute the given values for for the designed formula for this compound interest, then that will be 1 multiplied by 1 plus 0.005 raised to 12. Upon simplifying, if you use your calculators right away, so we can compute this one, and the resulting value for this one is 1.061677812 as the resulting value for your compound interest with this one. So for step number 2, let the equivalent 1/2 year rate be your T%. Note the equivalent yearly rate would be 2% here. No? Now find the value of 1 peso invested at T% per year, 1/2 year after 1 year. So your A now is 1 multiplied by 1 plus your I, your interest rate, raised to 2. Note that N is 2. The number of times interest is compounded because it is semi-annually. No? These two amount must be equal. Hence, no? Let's try to solve. If we simplify 1 plus 0 plus 1, I raised to 2, that will be equal to 1.061677812. If we take the square root of this one, that will be 1 plus 1 I. No, square root of 1.061677812. So that will be equal to 1.030377509. So that will be your 1 plus I, no, as the value of this one. So this will be the resulting value if we take the square root of this one. No, your 4i, so we just simply transpose this one, no? We just simply transpose this one to another side of your equation, and to make it from positive to negative, so we subtract this one to this value. So here there is a minus 1 here because we transfer or transpose this positive one to another side of your equation. So it becomes 0.030377509, or if we convert this one to percent, we multiply this one by 100 to make it 3.0377509% for 1/2 year, or every 6 months. So therefore, the equivalent 1/2 year rate is 3.0377509%. Now, we can illustrate the cash flow in this case, no? So the payment, for example, is 700 pesos for the first year of payment up to the last year of payment, which is 24. In this, meaning, say, right after your first month, your first term, which is after 1 month, so that will be 700 pesos. Here, as you can see, after 1 month, there's another 700 pesos. In this case, it's another 700 pesos. No? So that's how we illustrate the cash flow up to the last month of payment here. So the future value of all the payments at the end of term, so after your time or term, which is equal to 24 months here. So again, using your time diagram, your payment is 700 pesos in this case, no, for the first month payment, 700 pesos for the second month of payment up to the last month of payment, which is 24 after 24th month as the period or year, as you can see on this time diagram. On how we compute for the future value is the same process. No, we apply your uh, compound interest. On how we compute the compound interest, then we apply to the principal, which is 700 pesos per month. No, for the first year of payment, why is that? It is 23 because we subtract 1. No, to your 24. It's the same with the second year of payment. We subtract 2 to your 24. And the third year of payment, we subtract 3 to 24. That's why it's 21. After the last year of payment, it's the same process. So now we compute. Now, in this case, to add all the future values obtained, no, from the previous step, we just simply add all the future values that we can get from these computations, no, from your time diagram. So the resulting value is 24,212.83 pesos. So that is the resulting value for the future value of all the payments at the end of 24 months. So for the activity, so answer the following. So first, why is it that many Filipinos do not save or save very little? Research the top 5 external factors or barriers to saving. Your answers should be supported by recent data. Cite your sources for the data gathered. For number 2, choose one topic from the choices shown below. Ask someone how the payment investment has been made. Make research on some strategies on how to reduce or gain interest in the chosen topic. So first, insurance. It can be insurance, time deposit, educational plan, housing loan, retirement plan, or investment. So this is your activity for this module. So you can put all your answer in your Katleya notebook. So it's the same process on how you deal with this one, no? Uh, on how you are going to pass this activity, no? Together with the other activities from the other modules. So thanks for watching. So please like and comment and subscribe.